Go ahead. Hello, and thank you for joining us for the Download Community Tech Talks Episode 7. These are community tech talks for the community, by the community. We're really glad that you've been able to join us today, and we'll ask you, while you're here, please share. Please let others know that you're here with us, and use our hashtag Hpcc Tech Talks. Please also ask questions. We really do enjoy the questions at the end of every presenter, and we look forward to hearing your questions. Also look for the polls at the bottom of your screen. If for some reason you're not seeing them, exit the full screen mode or refresh your screen, and they should show up at the bottom. And please know that we welcome your feedback. At the end of the session, we would love it if you would rate us. It helps us to get better. We also want to thank everyone who participated in our survey. We got an overwhelming response, and we got some very good comments. So please know that we're going through those, and as we start planning for our spring Tech Talks and the end of our fall Tech Talks, we'll be incorporating your data. And many thanks to the people who volunteered as speakers. We had 3 people raise their hand, and we will be reaching out to you shortly. And if you'd like to be one of our speakers and you didn't let us know before, please just send us an email, techtalks@hpccsystems.com. All right, at this point, I'm going to hand the mic over to Flavio to kick us off.
Hello, everyone, and thank you again for being here. This is going to be a wonderful episode of our Tech Talks. We have a number of presenters that will be covering very exciting points. But before to get to that area, I want to give a few pieces of news. One of them is, remember that we have our 6.4.0 version, and if you didn't know that it was out, you should be checking it out right now. That's the latest and greatest version of the major 6.0 series. This is 6.4.0, and 6.4.2 that is release candidate right now available as well. There are a number of areas that have been improved in that. As you know, it's a minor release, so don't expect to see earth-shattering changes, but there are a number of improvements that are part of that release. Now, in addition to that, we have a great piece of blog that was published just yesterday, so this is pretty hot news, on our support for PB BLAS. And if you don't know what PB BLAS is, but you're familiar with BLAS, hopefully, I can tell you that it is a way to partition matrices and vectors across a cluster, across a large number of nodes, in our case, your Hpcc systems cluster, to do distributed processing on these matrices. So this essentially is any linear algebra operation. This is not just quite useful on its own if you have any math to perform across a large number of matrices or a very large matrix and vector, but also it is the core technology underpinning the scalability that you can see in our machine learning libraries, which rely on PB BLAS to do this type of operations. So there are in this blog a number of interesting tips and tricks around PB BLAS, and there is a good description of what it is, what it can do. So I do recommend highly that you head on to our blog's site and take a look at that blog. It's very, very interesting. Now, in addition to this, we have our 7.0 version chugging along. We are working actively on developing each one of the scheduled features in the roadmap for 7.0, and we are at the point where we are pretty much feature freeze, which means that we know what is going to the development cycle, and we have our developers actively getting those features into the system. We expect it to be released towards the end of first quarter next year, so first quarter 2018, and I can't believe that we're already at the middle of 2017. But this is going to be a major release with a number of significant enhancements. Some of those are on a screen. As you can see, the underlying theme across it is better usability. It's easier to use, faster to use, simpler to understand, And there are a number of areas that have to do with the user interface, with better integration with other projects and code bases, like, for example, the Spark integration, with more machine learning support to make it easier for users to use machine learning on HPCC, and on and on. There are a number of resources where you can get more information on this 7.0 release, including our GitHub repositories, which I encourage people that are code inclined to go to the GitHub repositories and take a look, and maybe clone the repository and play with it, and certainly compile it yourself if you want, or get access to any of the early versions of the snapshots. But certainly it is a lot to look forward to for that release, and there are many more things that I couldn't even cover in this little talk. So I do encourage you to go and look for information on 7.0. This is going to be a very significant improvement. Now, beyond these community announcements, I want you to remember that our Hpcc Summit is around the corner. Sorry, the screen just moved on too much. There you go. So there is still time to register for our Hpcc Community Summit, and that will be just around the corner again on October 3rd and 4th, 2017. It will be here in Buckhead in Atlanta. So for those that are in the area, this is something that you cannot miss. This is a one in a year well, almost one in a lifetime, but a one in a year event that is a poll attracting all of the community members across a number of different areas of interest and different competencies and different core talents and skills. So this is highly recommendable. If you haven't yet, please register, come along, take a look at what we have, enjoy this event, and share with the rest of the community, and potentially that might be the start of collaborations beyond that. We do want to also thank our sponsors. We have now 3 sponsors: Cognizant as a platinum sponsor, Infosys as a gold sponsor, and Datum Software as a staffing sponsor for this event. We really couldn't do it without the community and without the sponsors. We believe that the event will exceed your expectations, so I hope everyone enjoys it as much as we expect you to. Now, for this Hpcc Community Day, we will do something that we haven't done before. As you can see on a screen right now, we will be having a pre-event workshop. This, we believe, is a good idea, because since people will be already in the area for the event, what better than taking a little bit more of their time to help them learn a little bit more about HPCC. And this has a fairly ambitious scope, because it certainly tries to cover the basics, but it tries to cover the basics in a way that it compresses time and gives you enough to be able to go into the workshop with very, very minimal knowledge of HPCC and come out with enough knowledge to be able to code and produce your own systems and applications on top of HPCC. I hope we can make this dream a reality. I hope this works. Certainly, you know that you have all of the online content, which is essentially self-driven content in our massive open online courses. But if you really value having a trainer in front of you that can help you with questions and answers in real time, and the face-to-face interaction and learning with others that are learning at the same time in the same room, well, this is a great opportunity. So do not miss this pre-event workshop if you think that this is a fit for your needs. And for the Community Day agenda, which is now on screen, you can see that we have a number of already well-defined tracks, and we have great sessions from excellent speakers. We will, as you can see in the screen, it's very hard to condense all of this information in just a single table. but we will have more detailed information about each one of the talks. We have been going through some of the rehearsals already, and these are all excellent talks and excellent sessions, including very cool panel that will happen in the afternoon, in the early afternoon. So if you have any doubts about coming to this event, I think this should clear up all those doubts, and please go and register and plan to come, because this is going to be great. It's going to be a great event, and I'll certainly enjoy it very much, and I hope that every one of you do as well. Okay, now for the I'm trying to push the interface for the next slide, but it wasn't coming quick enough. There you go. So for the today's speakers, we have two speakers, and the first speaker, who you might or might not know, is Ming. Is one of our LexisNexis consultant software engineers. He has been involved with Hpcc for a very long time. He is part of a team of software developers and technologists that drive some of the capabilities on top of Hpcc, integration capabilities, user interfaces, ECL Watch, and others. And he will be talking about a particular project that I personally pushed initially, which is our integration with the Jupyter framework. And if you're not used or you don't know much about Jupyter, Jupyter is a framework that allows you to create literate documents or code. And the best use case for something like Jupyter is to create, for example, a scientific paper that can be run, that can be executed, and the code can run out of that, and you can potentially even change the code and generate dynamic visualizations and other active components into the document itself. This is quite useful in academia, certainly, and outside of academia for presentations and demonstrations and others. And it supports a number of back-end technologies. In Jupyter, you can have code that runs in Python, and you can have code that runs in Spark, and you can have code now that runs on Hpcc. So if you have a very large data set or a small data set, and you want to have a dynamic visualization that is part of a document, for example, Jupyter is really the way to go. And as an example of an application, and also as a little bit of a teaser on what we will have, I want to also let you know that our sister company, Elsevier, who runs the Big Data Research Journal, will be running a special issue of Big Data Research on Hpcc, and will be pushing Jupyter or Jupyter-enabled papers as the underlying theme for that special issue. It is in some ways a little bit of an experiment, and this is a nice disruptive experiment where you can get now papers that are essentially active, that contain code, that can run, that can generate visualizations. And it's something that might end up picking up in the entire research community. So if you have the interest on publishing a paper in some new disruptive methodology of publishing, and you'd like to give this a try, I highly recommend that you take a look. Go to our Big Data Research Journal site. There will be some announcements around this special issue, which will run for the next several months and eventually be published. I would estimate that it will take a few months to get the publishing going. But start preparing if you have some interesting content that you think it can fit this particular medium. And the second speaker today, and he's last but not least, is Bob Foreman. We have a very interesting talk, and it's hard to say that because Bob has always interesting talks, and he has done some of these type of interesting talks in the past. But this one is also driven by some community requests. When we did the survey to the community, some people were asking for more tips and tricks and real-world useful nitpicked information that can help them do things easier and better in Hpcc. So in this particular case, he will go through the aggregate and process transform functions. And he is always a very good speaker, so I'm pretty sure he will make this very, very interesting. So without more preamble, let's go to Ming then. Ming, the floor is yours.
Okay, go to the first page. Oh, okay. So I will start to introduce what is the Jupyter Notebook. So the Jupyter Notebook is an open source web application that allow you to create and share the documents that contain live data and equations and visualization and explanatory text. The uses include data cleaning, transformation, numerical simulation, statistical modeling, machine learning, and much more. The main feature about Jupyter Notebook including in-browser editing for code and ability to execute code from the browser, and display the result of a computation using the rich media presentation such as HTML and LaTeX, PNG, and SVG. In-browser editing for rich texting using the Markdown markup language, and also you can download and as various formats such as HTML, Markdown, and PDF to finalize your report. Now, the Jupyter supports multiple language, and through the kernels, the default kernel for Jupyter Notebook is IPython. The other current available one is in this URL I present here. Now, for Hpcc part, we implement a new kernel called Hpcc ECL, TS-ECL. The TS-ECL refers to the ECL kernels implemented with TypeScript, which is a superset of JavaScript. The TS-ECL implementation reference iTypeScript kernel that include IPECL kernel modified from JP kernels, and mainly is utilize the Hpcc JavaScript package developed by the Golden Smith. This package actually allows you to communicate with ESP to submit ECL code, and then you get back the work unit result. The following is the GitHub link for the project. The current TS-ECL feature and the limitation. The features include you can configure the ESP such as the IP port, cluster type, etc. And also you need to test the connection before you do the real code. And then you can write your ECL code to execute it, and then also can display the ESP configuration. And also, since it's JavaScript implementation, you can run the JavaScript code. Now, the limitation is we only return the first work unit result. And another limitation for now is there are no ECL syntax check yet, but we will improve it soon. Now, for user to play the Jupyter Notebook Hpcc package, there are 3 ways. The easiest one, you can download the VirtualBox image. But this link is only internal. It's only the inside Nexus network. You can download it. Another way, you can go download the Docker image that is public available for everyone. The third option is you can follow in the GitHub instructions that allow you to install all the prerequisite and TS-ECL packages. Now, before I go to the live demo, I just want to show some screenshots for what I want to do. Basically, when you connect with the Jupyter Notebook servers, you first want to select our kernel, that is Hpcc ECL, TS-ECL. And then usually you want to give a configuration for your ESP, IP, port, and etc. the cluster. And then you run that cell, and then you get confirm the connection is okay. Following, you can just do whatever you want. You can write articles. You can implement the code. So this way, here I show you you can implement. You can insert a code you want to run. You can get the result. Now, after you run after you get result, you want to finish your articles. You can. Oh, sorry. This is how you run it. This is when you click the run cell, it will run your code. Okay. And if you want to output your articles, there is a file download, and you can choose a different format. For the PDF or some other format, you probably need to install. You need to install additional software, but HTML and Markdown is by default available. Okay, this is the I just put here is HTML format the articles. This is a simple one, so I just put there for what it looks like. Okay, so I will go to a live demo now. So I have the VirtualBox image installed already on my system.
Ming, just a moment. Would you perhaps minimize your BrightTalk screen so people can see your full screen share?
Okay. Is that okay now?
Perfect. But expand your screen so that we can
no,
see it a
sorry,
little bit.
Let me see. I don't know why. Let me see. I did connect my VirtualBox.
There you go. That looks good. Right now it looks perfect, Ming. You're set.
Yeah, but I don't know why this screen doesn't show what I type. Let me just close it and then quickly bring a new one. See if it enchanted. Demo.
It looks like it's working now. At least we can see you typing, so that's perfect.
You can see my, okay. Why is so slow? Can I just use this VirtualBox image because I already logged in and yeah, it's a little.
Absolutely.
Yeah, I just started the server. Yeah. So basically, for the sorry. Oh, I don't have a. Okay. Okay. So I start my Jupyter server on my VirtualBox image. So now I go to the browser. So that's 10.176.152. The default port is the 888. Now, there is a password in our VirtualBox image. The password is Hpcc. When you log in, I did print on the screen, so you should see it. So now I'm in the Jupyter Notebook. Now, just as I said, the first thing you want to do is you want to select our kernels. That's Hpcc, ECL, TSD, ECL. So Okay, so I have a cell. Now the Jupyter notebooks use a cell to manage your code and your articles sections. So we want to connect one of the ESP server. I will use our demo one. When you can run the cells, click the run cells, and also you can use this shortcut. Okay, so when you see the connection with Hpcc ESP server succeed, that means you connect with our Hpcc platforms. So now you can write your ECL code. I want to add another cell following. So I just copy and paste the code from our playground. Okay, so now I want to write. Yeah, so you get the results just like you run the code from the ECL Watch or what other editors. So now, by default, the Jupyter Notebook give you a title for your articles, but you can change it. Say I want to see my test, and then rename it. And also you can output this article. See, I want to see output, download it as HTML. Okay, so this is the result. So this is the HTML page you just created, you just run. Now the one thing about the Jupyter Notebook is you can share your articles and other people can run the code what you have. So how to do that is let's go back to the Jupyter Notebook. From the file, you want to see I want to open a file. Now all this file is a directory you start your server, your Jupyter server. But if you have others, you can upload the other files. The default, the Jupyter Notebook's articles extension is IPython NB. I will use the one my colleague Jim created. So this is Jim test. So I will click that one. So you can see this is a small tutorial Jim created. They have some instructions, have some code. So first thing I want to do is, since we use a different ESP server, so I just make sure I can connect our demo server. And then I'm verified, I can connect with it. Yeah, okay, so it's okay. Now, for the articles, if you don't want any cell, you can actually remove it. The edit, you can remove the cell so your final article don't include the cell you don't want. Now, I will run Jim's code, but I want to do some modification. So here, there's a first person. I will make a small change here. Say, give another name. Oh, sorry. So, and then I just write. Okay, so now the result is back. So they show it's Joe Smith instead of original name. You also can verify that what we run on this demo server. See, this is a work unit we just run. Since Jim put a work unit job name, so we can see that's the one we run through the Jupyter notebooks. That is pretty much for the demo. Let me go back to the. Jessica, can you help me to go back to the slide mode instead of? Let's see.
All right, we're back to the slides.
Where is?
Are you ready for your poll, or do you have another slide?
I don't have. That's all I want to talk today. Yeah, so I can answer some questions and.
All right, wonderful. All right, so we'll give you a moment to take a look at the questions. And while we do that, I'm going to take a moment. I'm going to step back and look at our first poll. And the question was, have you used Jupyter? So it looks like 57% of you say that you have, which is fantastic, and 52 have not, 42% have not. So hopefully the 42% of you have learned something here that might be valuable for you in the future. And if you have used Jupyter, maybe you've got some insight on how to better utilize it with HPCC systems. So that's fantastic. All right, it looks like we've got a few questions here from the audience. So Ming, here's our first question. Are all features in Jupyter supported through this interface with HPCC systems? Are there future plans for enhancements?
Since the default kernel is IPython, that has more functions than the current one we use is the JavaScript kernels. But we will provide some useful features, for HPC. For example, the graphic or something. Golden will help us to do that. The answer is we don't support all the Jupyter features for now in the JavaScript kernels. But we will try to add more as the project go on.
Okay. All right. It looks like we have a few more questions that are in there.
Sure.
Take a look at those. Let's see. So in order to use Jupyter, do I need to have a full HPCC systems cluster deployed, or can I just have the ECL compiler available running on standalone mode?
You should have a HPC server somewhere, but it's not needed on your local system or the Jupyter server. For example, what I run now, I just go to our Diamond HPC servers we hosted, the company hosted. But you do have the HPC platform running. The Jupyter notebook doesn't have a HPC component. It only has an interface to communicate with the ESP and the HPC platform. I think this question is the same, right?
All right, here's another one. Are all the features in Jupyter supported through this integration with HPCC systems? Are there future plans for enhancements?
Like I said before, the Jupyter default kernel is IPython. That has more features than the JavaScript kernels. But we will add more features as projects go on. And for now, we only have some limited functions. You can basically do all the markdown as the Jupyter supported, and also you can run your ECL code. That's what we currently have.
All right, fantastic. All right, we've got one last question here, and that's what makes the Jupyter Notebook more suitable for use with HPCC systems over alternative notebooks?
Yeah, the Jupyter Notebook is very good for some articles or some tutorials. So, for example, if you have a tutorial to tell how to teach user to use ECL, you can have instruction, have a code, and people can run the code and can modify the code to play with it. Another area is in you want to add some big data articles with run the ECL code, so you can embed your code inside articles. You can share your result, and other people can verify, can modify it. So it's very convenient.
All right, thank you so much, Ming. All right, it looks like we've got all our votes from the audience in for our last poll, and the question was, could you leverage this new Jupyter kernel in your work? And 30% say yes, which is great news. 50% say not at this time, but perhaps in the future. So it looks like there might be a possible path forward. I'm glad we were able to share that. And for 20% of you don't think that's applicable, but it looks like for 80%, there's a good possibility that this could be good information for you. All right, wonderful. Ming, thank you so much for your presentation today.
You're welcome.
All right, I'm going to go ahead and pass the microphone over to Bob Foreman. As many of you know, we're very fortunate to have such a strong and robust training team here with the HPCC Systems group. And Bob today is joining us to give us some of his ECL tips.
All right, Jessica, can you hear me okay?
Yes, we can.
All right, fantastic. And all right, so let me just see if I have control of the slides here. There we go. So, first of all, before I start, Ming's talk about Jupiter reminded me, welcome to Hurricane Central right now. I don't know if you can hear it, but in the background, first of all, I'm very fortunate to have power and internet at my home, but in the background I'm hearing a lot of generators in our neighborhood. So I feel for those people. They've had no power since Saturday. So anyway, just wanted to let you know if you hear any humming in the background, that's what you're hearing. I had my grandkids with me too during the storm, and I told my grandson a joke because I was thinking about Jupiter, and then all of a sudden this joke popped in my head. So here, this is a joke for a 5-year-old. When does an astronaut eat? When does an astronaut eat? And the question there, the answer is at launch time. So that's the joke for a 5-year-old. And so
thank you, Bob. That's a good one.
All right. So our quick poll, now getting back to serious stuff, are you currently using the process or the aggregate ECL statement in your operations code? And I'm going to go back to the previous slide because when I started this talk, thinking about this talk, I thought about something interesting because in our classroom format, we talk a lot about iterate. We talk a lot about roll-up. We talk a lot about the basic transformation functions. But we mentioned process and aggregate in our advanced training, and we kind of give it kind of a glancing discussion and really just leave it to you guys. So I decided I wanted to do more of a deep dive into both of these today and talk about them. And looking at them, I think they go together because process is a logical extension of iterate, and aggregate is a logical extension of roll-up. But it's interesting, too, because when they step up and they upgrade their functionality, there's a few differences in how you treat the parameters, the things like the left record and the right record. So, again, the question, are you currently using process or aggregate in your operations code? And I'm going to talk about the language statements first and then jump into the code examples in the ECL IDE. Those of you that have listened to me in previous tech talks know that's kind of my method of operation here, where I'll talk about the code first, and then we'll go in there and actually look at some real-world examples and some things that are running. So the process function of ECL is well, my colleague Richard Taylor likes to call it a row state machine, and he says some people that know exactly what that means. To review, iterate was iterate was a way of processing pairs of records. And iterate has its purpose. Some of the most popular things I've used iterate for is you are working through a record set and you're looking at particular field values, and based on the contents of a previous record and something that's about to change, you can detect it in iterate and then apply that change using the transform. So that's the power of iterate. But iterate always had this one thing that everyone needed to know about, in that how its left and right records were being treated. The left record of iterate, the first record in the pair, was always the result of the previous transform. And the right record was always the current record. So we always knew that iterate, the first iteration that you would do, the left record would be blank. So process helps us overcome that limitation. Process starts with, again, a set of records, and this parameter here is a DS parameter. It then has a second parameter of the initial right record. And here's the first thing that you have to kind of change hats on when you go from iterate to process. When you go to process, the left record is always the active record, not the right record. In iterate, the right record was always the current record being processed, and the left record was always the last record being processed. Well, in the process transform, you have to reverse your thinking. The active record is left, and the right record is the one that is sent through the row transform. So you see here in these parameters here for process, we have the data, the record set, which is called DS, the row, which is your initial row. Then you have two transforms. One is the actual data set transform, and the other one is processing the row. So we're going to take a look at a couple examples of that. All right, so the next slide here, we have, this is some real simple code. I'm not going to spend a lot of time on this, but it's just showing you we have an initial data set of A, B, C, D, E at the top. Then we have a data set transform called XF1, and then we have a row transform called XF2. But I don't like this example because there's things there that just don't make sense to me. In other words, the row transform is just saying right letter 1 plus left letter 1, which is the first letter of each row, and it's only sending, because of the size of the record structure, only the first character, which is the right letter. So the result of this, as it goes through the data set A, B, C, D, E, the right letter, in the second parameter process, you see the row being Z. So for each row transform, it just says Z, A, Z, B, Z, C. So it's only sending Z to the data set transform. So in the result of this, you'll just see A, Z, B, Z, C, Z, D, Z, and E, Z. So it's very, very trivial, very tutorial here. So I'm going to show you some better examples as we get into our code. And before I do, let's talk about aggregate. So again, process being the extension of iterate, aggregate being the extension of rollup. And the thing I like about aggregate is it kind of puts on two disguises. It acts like a rollup, and it also acts like a table. And those of you that have been in training with me know the purpose of a table twofold. Number one, a table can be used as a vertical slice of a larger data set, and you can also use a table to expand a data set record structure if you need to do that. And also, the second purpose of a table is a crosstab report. So aggregate gives us some crosstab functionality by the last parameter shown here called grouping fields. So that's interesting. It wears kind of a table hat there for the grouping fields, and it acts like a rollup. But different from a rollup is that there's no condition here for the rollup. It's more of the grouping fields that determines the condition on when to break from the aggregate. So kind of real similar to a crosstab report, as you're going to see. So in this example, what makes aggregate so beautiful is that the input record set, first of all, doesn't need to be pre-sorted like rollup. The grouping field handles that for you. The left record is in the aggregate transform is the main transform of the aggregate parameter is the same format of the input record set, and the right record is the same format as your result set. And like I said, they can be the same, but they can also be different, which is a big difference from rollup. So in the transform of the main transform, left refers to your next input record, and right is the result of the previous transform. Okay, so keeping that in mind. And then we have this other parameter of aggregate called the merge transform. And in this case, the merge transform is only needed if it cannot be deduced from the normal transform, if the compiler can't work out how to merge. So another thing about aggregate, which is kind of cool, is aggregate is implicitly local. So it will aggregate your record on each node individually, and then it takes the result on each node and does a merge. And I don't know anybody out there who remembers how a merge works. A merge works with sets of data sets. So think of each data set being on a different node, and so as the aggregate finishes on each node, all the results get merged together into a composite result. So that's the engine behind the scenes for aggregate. All right, so let me jump out now to my favorite area, the ECL IDE, and I'm going to, let me see, I need to do anything with Join Me, or can I just do the screen share? I think I'll be good with that, right?
You should be.
Let's see, screen share. All right. And let me go over to my ECL IDE. And how's that? Can everybody see my ECL IDE?
We see your BrightTalk screen.
All right. Well, I'm all tabbing over to my ECL IDE right now. So maybe do you need to do something in the Join Me software?
You're probably right, Bob. This one's on me, everyone. Sorry.
Viewer 2 would like you to present. Okay. Why not? Why not?
Thank you, Bob.
All right. So now my screen is being shared. You're welcome. No problem. All right. So now my ECL IDE should be visible. Can everybody see that nice light blue screen? Everybody there now? Jessica?
Oh, yes. Yes, Bob, I apologize. I was on mute. We see it perfectly.
Yeah,
very clearly.
Make sure everything's cool. And actually, I can zoom in sometimes, too, so that's good. All right, zoom in will work. All right, so let's talk about the code. This is the code. First of all, this is our first process example where I'm talking. I normally show this to the students in class. It's a much better one than that one on the slide. It starts with a data set here of AA, BB, CC, just an inline data set, although the data set is defined as a string 4 for that first field. So we're initializing the first 2 characters of that letter field to AA and BB and CC and DD, etc. Down here at the process, we're processing the data set, which again is our inline data set. We're initializing the row to ZZ, and ZZ is using the record structure of the state record right here. And then our data set transform passing the left and the right, and our row transform passing the left and the right. So again, the first time that process gets called, the left record is going to be the double A, and the right record is going to be double Z. So we take the first 2 characters from the left, which is AA. So I'm in the transform right now, line 12. And then the next 2 characters from the row is ZZ. So at the end, these 2 down here are just reflecting left and right. So this is going to be AA right here, and this is going to be ZZ down here. So after the first process cycle is complete, self.letter will contain AA and ZZ. So now we cycle back to the second process, and before the right record says, okay, take the first letter from the left, which was originally A, and the first letter from the right record, which was Z on the last pass. So the right record in the second process is going to be AZ. So again, our second record is BB up here from the inline data set. Our row record is going to be AZ. All right? So then we continue. We say, all right, if that was if our second result was BBAZ, then we take again the first from the left, which was B, and the first from the right, which was A, and so we start with then BA, and then you can work it out to CB, and then finally we have EEDC at the very last record. All right, so it's just what it's doing is seeding the row before each process. The left record being the current record being processed, the right record being the record that is sent from the row transform. All right, so real world example. I was in the forum a few months ago, and someone said, I want to iterate through records, but I want to seed my first record with some kind of a value and then draw on that and then continually use the previous record of the last iteration to do my calculations. And so this is a real simple example of what that person was trying to do, but the answer was process. Process to the rescue. Instead of iterate, he couldn't do this thing with iterate, so process was able to help him. So in other words, what he's doing here is he's got a data set here of 2 and 3 and 5 and 7 and 7 and 7. And he said, okay, I want for the first row, I want my first row, my right record, to be the first record of the data set, 2, 3. So in this transform, the left record is going to be 2, the right record is going to be 2. The left record is going to be 3, the right record is going to be 3 for column 2. So in the first pass of the process, 2 minus 2, 3 minus 3, we're going to get a result of 0, 0. Now, his row transform is just saying take the left record of the previous iteration, which is kind of cool. So now his left record in the second pass is 5, 7. His right record is now the record from the left of the previous cycle, which now becomes 5, 7, and 2, 3. So we have 5 minus 2 and 7 minus 3. We have 3 and 4. So you can see the results here. I'm going to zoom in on this. 0, 0, 3, 4, 2, 0. So he was relying on the previous record to do calculations on the subsequent record. So that's process. Process using, and this was kind of interesting because it wasn't using the row function that you see in the language reference manual. It wasn't using a real row transform structure. It was just using an inline transform to accomplish what was needed in this application. All right, so let's move on to aggregate now. And first of all, this one I'm just going to briefly touch on because this one is in the language reference manual, and you can copy and paste this, and you can actually run this example and look at it. And essentially what's being done here is we've got an inline data set of a box number and the contents of the box. And similar to rollup, we're putting all of the Freds and Freddies and Fred John here into one box. Any box number that matches, all of these values are getting concatenated and placed into the subsequent output result. And so you're going to see something like this when you run this example. Box number 1 has Fred and Freddie and Fred John and Fred Head and so on, all these different forms of Fred. So that is the example that is in the language reference manual. So I'm not going to waste time with this one. I'm going to show you a couple of interesting examples. One I did just yesterday because I wanted to kind of really just exercise aggregate a little bit and show you how it would work with a real data set. So this one, first of all, this one was one that my colleague Richard Taylor actually came up with as a solution on our forums. So this gentleman had contacted Richard, and he said, I want to do some stuff with my data values, but I need to keep the result of my last calculation and use that in a subsequent calculation. So we came up with aggregate as the result here because the beautiful thing about aggregate, unlike rollup, is that the output of the aggregate, being this result record, can be different from the input, which was the input record. So this input record is using a real and something called value, and the output record was this result record that was a real and an integer, a counter value. So you see, as he's aggregating this filtered data set, okay, only looking for valid decimals and, so rejecting strings or whole numbers. He's only using decimals here. That's the isValid function. And then he's saying send the result to our result record and call this transform called T1, and we have our left and our right record. And then as you see here, the right record, which is always the in aggregate, remember, your right record is always the result of the previous aggregate. And so, unlike rollup where left and right, the left record was always your active record. Right record is always your current aggregate total. So you see here what's happening is that if the right count in the first time was 0, which it will be because we haven't done anything with this counter yet, so we're going to initialize it to 1. Otherwise, we're going to use what's in the right value. And then he's calculating this on each cycle to use this previous value to control his computation. But the interesting thing about this aggregate result is this aggregate result is only outputting just the first field from the result record. So he was using the counter as kind of like a temporary value there while he was working with the transform, but then he said, okay, really the only thing I'm concerned with is this real value. And you could always then project it and put it into a proper record structure if you want to do that. So, by the way, this aggregate also has no grouping fields, so it's going to loop through this entire data set and then calculate everything that it needs in one complete pass and do this aggregate value. So you see the result of this is 1 point decimal, long decimal there. So this was a solution using aggregate. We were able to, but because of the fact that roll-up, the input and outputs have to be the same, we're able to say, okay, well, here's an input record structure, here's an output record structure with a different field, and I can use that field in the transform to work with intermediate values. All right, so the last example I want to show you is one I just did yesterday, because I was kind of thinking about, let's do one with a data set. And by the way, all of these examples will be available for download. They're actually up there already. Jessica and Trish did a fantastic job of getting it all posted. But I do want to say something. This last example that I'm going to show you is working with an actual data set that I sprayed. So we're using the training data from our classroom. We're using a person's data set and an accounts data set. Those of you that take the online lessons, you'll be able to get those data sets from the online lessons. And if you have trouble with that, if you want to run these examples and you want some kind of sample data, please just send me an email and I'll work out something, or I'll show you a cluster where you can download these particular data sets. So I'm working with our classroom data sets. Before I show you aggregate, before I go ahead and wrap this up with aggregate, I want to show you, first of all, look at this code. This code right here should be familiar to a lot of you. It's a simple crosstab report. So I'm taking a contents of an accounts file, and I am breaking on the person ID, which is our link field to the persons file, by the way. And I'm actually doing a count of how many accounts do we have per person, how many account records do we have per person, and then I'm also summing the account's balance in the crosstab report. And so in this example right here, you'll see that I have this result of a person ID, and this person has 36 accounts, and their summary, their sum of all their balances is 257,767. So this is a crosstab report. And I did this for validation because I'm glad, remember this number right here, 257767. 257767, because now in this next example, I'm taking both the accounts file and the persons file, and I'm going to join them together. I'm going to make one nice big record structure of persons and accounts. And by the way, by using a join, you all know what's going to happen there. If this is a parent-child relationship and I'm looking at this link field down here on line 16, I'm going to have a number of duplicate parent records. So when I do this join of persons and accounts, you'll see that in the result number 1, I've got a lot of duplicate parent records. So there's this guy, Bertie Mousseau, and his person ID, and so on. So the parent file is being duplicated for every child record that's processed by the accounts file. I did this because I want to aggregate it. So now I'm going to take that joined data set that I built, and I've got an output now of just the 2 fields from the accounts file that I'm interested in, balance and high credit, and then all the person's fields can come along for display. So here I've got balance, here I've got high credit. The aggregate input record set is this join data set, the result of my join. The output of my aggregate is this output record structure here. I'm calling a transform called aggregate them, left and right, and my grouping fields, here it is, left.id. I'm breaking on that ID field that links the person's file to the accounts file. As each record gets processed, I'm taking the right value of the previous aggregate and I'm just adding it. I'm doing a sum. I'm just doing accumulation here. And for balance, balance plus left balance. So what will happen here is aggregate will keep adding, and keep adding until the left ID breaks, everything resets, and then we start the process all over again. So this, again, to review, here's your input of aggregate, here's your output of aggregate. Both of them are different. Here's the transform, and I don't need to do a merge in this example because the calculations are simple. And by the way, I'm going to say 99% of the times you don't need that merge transform because the compiler, Gavin Halliday, if you're out there, one of the most brilliant persons on the planet, the Mr. Compiler, he will work out this stuff for you. The only time you need to step in there and do a merge transform is if you've got some complex relationship in the transform and the compiler doesn't know which way to go with it. And so sometimes you need to tell the compiler, and by the way, the compiler will probably tell you then, I don't know how to merge this. You need to tell me how you're going to merge these records together. So in all the aggregates that I tested, I really haven't had a need to use a merge transform yet. Down the road, maybe I'll find something and I'll share it with you all at a later date. But right now, as you notice, this aggregate doesn't require a merge transform. And, well, let's take a look at the results. So once again, here's our original joining of all the parent and accounts information. And here's our aggregate result. And if you take a close look, I asked all of you to remember that number, 257767. And you see there's Bertie Mousseau, and there's his balance, his sum of balances. And there's the sum of high credits for each person. So aggregate here was very, very useful for me, and I can cherry pick what fields I wanted from the child records. I can do sums, I can do averages, I can do anything I want in that transform for each of the child records. So there it is. That's a good real-world example of aggregate and how useful aggregate can be. It's another way of approaching crosstab reporting and analysis of parent-child relationships. And so again, it combines the best of roll-up, it combines the best of a table, and there you have it. There's our aggregate function. So let me jump back over here. And Jessica, you can go ahead and take the screen back, and I'll open the floor for any questions.
All right, fantastic. So we have one last poll here. How many of you outside of LexisNexis or other RELX Group companies are planning to attend our October HPCC Systems Community Day event? We certainly welcome everyone to join us, and hopefully, even if you can't attend in person, hopefully you can attend online via our live stream. So that, of course, is available free and will be live during the entire event, and you would have an opportunity to even submit questions. So we'll be monitoring our social media accounts and taking your questions. All right, so Bob, while you're reviewing the questions, we'll look at your first poll, and this actually is really interesting. So the question was, are you currently using process or aggregate in your operations code? And nobody is using only process or only aggregate. So that's interesting, no one. A third of you are using both, and 70% are not using either one. So again, hopefully you've learned something from today's talk, something that you can take back into your work and be more productive. All right, so it looks like, Bob, we've got a few questions here.
Okay.
So,
yeah, the first one, go ahead, Jessica, I'm sorry.
No, go ahead, Bob. You can read them.
Are both iterate and process equally efficient? Should I use one more than the other if either one works for my use case. Okay, so the answer to that is iterate simpler than process. If either one works for your use case, you should use iterate. Remember, process is only used if you need to initialize the row and use that row state machine for subsequent iterations. So again, it just provides a little more bang for your buck using process. They're both equally efficient, trust me on that. I mean, this is one of the hardest things I have sometimes to convince people. Let the compiler do the work for you. Don't try to overcomplicate things. Let the compiler, keep things as simple as possible. And then if you need to add an attribute to a particular function, then do so. All right. So is there a difference in performance for table versus aggregate for doing crosstab aggregation? That's a good question. I sure could do a timing test on that. It depends on probably the complexity of both the table and aggregate. I probably say table is simpler to use. And you saw what I used with aggregate was pulling the records together and doing more of a roll-up. So when you need to do a group by or a crosstab, but then you also need to roll up records. That's where aggregate comes into play. Are both iterate and process equally efficient? Okay, we already got that question. And then could I achieve similar functionality to aggregate if I use the table and a group keyword? Well, yeah, for the grouping fields, yes, but aggregate has other purpose, other function. In other words, it does the roll-up as well. So it's a crosstab report with a roll-up. So there are applications for using aggregate sometimes that would be better than using just a simple crosstab report. I think that's it.
I think that's it.
Questions, everyone?
Yes.
And I say one more thing, too. I really want to encourage those of you out there that can attend the Community Day training. It's been a labor of love for me. When we were talking about this as a group and we were talking about the challenge of a single day of training, something that would challenge and encourage people and be very interesting to people on a Community Day forum, I decided to really roll with this and put together kind of the best elements of all of our classes. So you're going to find in this Community Day training, first couple of hours will be an introduction to ECL for people who have never seen it before. But then we're going to roll into transformation. We're going to roll into elements of our Thor class, elements of our advanced ECL class, and then finally elements of our Roxy class. So it's going to be a very ambitious endeavor, and I'm ready for the challenge. There's going to be a lot of code that I'm going to be presenting to all of you, and things are very simple, and then other parts of it will be more complex, and you'll be able to take home all of it. You'll have a complete handbook, code examples, slides that you'll be able to take back and then actually work with the code examples and hopefully find them useful. So I really want to push that. I'm kind of excited about it. We already have a few people signed up, and a number of other people from our hackathon that are going to be coming in. Some of our students from Kennesaw State. So I hope some others of you can attend, and I'm looking very forward to presenting that and meeting you all personally.
Fantastic,
all right.
Bob. We're really excited about it too. And I just wanted to add an extra note that for students, we have an outstanding discount. So I think there's an email address that you can reach out to. It's students@hpccsystems.com. Just send us a note. We'll give you the discount code, and we would absolutely love to have you. So, all right, just really quick, Bob, looking at the results of your poll, it's basically everybody who voted is planning to come. So we're thrilled about that. It looks like a quarter will be attending on live stream, and the other folks will be attending in person, which is wonderful, so we'll see you there. I just wanted to take a moment that we had one late question come in, and it was, would the HPCC Systems Visualizer bundle work on the Jupyter network? And the answer to that is at the moment, not yet, but it is definitely on our roadmap, and we're looking to get that done. So the person that answered that question, I'll try and reach out to you afterwards just to make sure that you get that answer. And that's a wrap for today. So for those of you who would be interested in submitting a talk for an upcoming episode, we would absolutely love to have you. Success story, a new use case, applications that you want to demo to us. As usual, we're always open to ECL tips and sample codes or suggestions to our roadmap. Feel free to reach out to us and let us know. The emails are there. Within a few business days, we'll have a blog up and running about this to download here, summarizing everything that we've talked about. And please remember to visit our website for more information on the summit. As a quick reminder, there will not be a tech talk in October, mainly because we're doing our live stream and we've got all of these fantastic, wonderful speakers in our summit. All right. Thank you all so much. Have a great day.